Hi everyone, I am Matteo Collina. I'm here to talk to you today about GraphQL. Please take a moment to follow me on Twitter at Matteo Collina. I tweet about various things and so on, technology, open source, ramblings, I don't know, making things fast. Note that I'm a technical director at Nearform, so we are a professional services company based all over the world. So if you need some help with JavaScript or deployments or architecture, software architectures, whatever, we are here to help. So let's get started. The topic of today is GraphQL and making it fast. Well, first, let's talk a little bit about GraphQL itself. GraphQL is a language that was invented by Facebook to describe their entirety of their own APIs. And, you know, we can start from describing the how you could model Facebook using REST. With REST, which REST and HTTP1 and so on, you will do a get to get your Facebook friends. And these will return a list of your friends, right? You would build this type of API if you were doing REST. But if you just want the names, what would you do? Well, you will create a new endpoint, right? Or you might create a query parameter with an option. I don't know. This is non-standard, okay? It's actually very, very hard to measure this type of, to build this type of things in a standard way. So it's one of those problems. And this means that whenever we are building new clients, and we will need to, there's no standard way to interact. So it becomes harder and we need to reinvent the wheel the whole time. It turns out that in some long time ago, I was building an API for a mobile app that had, I don't know, different endpoints for Android and iOS because they wanted the data in different ways. So I don't know. But that's what kind of happened when if you want to have if we add the likes. So we want the friends and the likes. So two endpoints to make one call. Or should we create Facebook friends and likes? Well, GraphQL was built to solve this problem. GraphQL was built to enable a more responsive communication between the front end and the back end of an application. And it can also work, for example, great on mobile, on VR, and also, of course, on the web. So how we build stuff with GraphQL? Well, we start with doing a very, very simple query, which is we can get the friends. And we want the friend named Matthias. And we get the name of the friend named Matthias. Hello. And, you know, this means that we can only select the properties that we want to see, which is great because we don't have to, given that the user sent us this query to the GraphQL endpoint, we don't know this filtering and removing properties that the client will not need. It's actually something that GraphQL does us for free. Well, I will talk more on that later. It does it for free in the sense that we don't have to code any logic and we don't need to build anything, which is pretty great, right? I love it. However, you know, it's this works because we have defined the types. So you see we get the friend, we have the name, the country, and the age, and we have a friends query that return a friend. Pretty neat, right? This means that, you know, GraphQL is also self-explanatory and it's introspectable. So you can actually query a GraphQL endpoint to know the schema of that GraphQL endpoint, which is kind of, you know, you can ask GraphQL to describe itself, which is pretty cool. And it's you win the query. So you define your types and then you define your input, your query input and output. Pretty cool. You can also ask two things at the same time. So if you want to have Matthias and you want to have Matteo, you can actually ask the two things. You can actually do the two things in parallel. You can also specify names, you can also specify different properties. You can name those queries, note those results. It's pretty great. In fact, you can even have variables in there that you can pass in, which will look like, prepared statements, and so you can avoid, GraphQL injections, of course. All of these has created a super rich ecosystem in the GraphQL community, which is fantastic. And because you can have libraries for all possible languages on the backend, on the front end. We can have full backend as a service systems that implement GraphQL, so that you don't even have to touch the database. GraphQL is your database. You can build the microservices systems with GraphQL. You can create amazing things, and you can buy GraphQL systems from everybody, or you can implement your own in Java, node.js, Go, you name the language. So it's pretty great. Well, because it makes prototyping easy, because you can actually quickly discover things in GraphQL, create your own queries, run them, and you can actually build them things really, really easily. Well, however, all this goodness comes at a cost, which is pretty steep to some extent. One of the key problems is that, so just one step back. Since 2018, several of our customers, Nearform is a professional services company, as I said, reached out. They started migrating from REST to GraphQL, and they saw that their GraphQL implementation was underperforming compared to REST. Okay, well, what can we do here? Now, the problem here is that when we start doing this type of things, we have our own toolkit for performance work, which is called Node Clinic. Node Clinic is a really nice toolkit that enables us to diagnose performance issues. So we started investigating in their Node.js application, our client's Node.js application, why GraphQL was underperforming. So we have used, for example, Clinic Flame, which generates with a very, very simple query, and which generates a flame graph like this. And we have started using these kind of techniques to investigate how the GraphQL.js implementation, the reference implementation of GraphQL was working. Turns out that we have discovered quite a few interesting pieces. First of all, for every incoming request, the server first has to parse the query to produce an abstract syntax tree and then walk that to execute the query. Wait, not just walk it once, it walk it twice, because it needs to validate the query and then execute it. So apparently it has two executions that needs to happen. As every performance engineer will tell you, making things fast, it's basically making things not being executed at all. So whenever you are doing any bottom-up optimization, you can actually very quickly see that caching is one of the key techniques that you can apply almost everywhere, so that if you have seen those type of things before, you can actually not do the work, which is fantastic because we can actually cache our abstract syntax trees. Well, turns out that since 2016, I've been working on a web framework called Fastify. So I have started building an adapter for Fastify GQL back in 2018, and GraphQL in 2018. And in fact, you can install it using npm install Fastify GQL. It's pretty great and it's neat. Hey, hooray! And in fact, it's actually very simple to use. You can actually install Fastify GQL, create a Fastify application, and then register GraphQL, our Fastify GQL, passing in a schema and some resolvers. It's pretty great. The resolvers are, if you haven't seen this before, the resolvers are how we implement the queries that we're going to add. And it's pretty great, right? It's simple. Now, I've started working on making this run fast. How? Well, Fastify GQL uses a least recently used cache, LRU, to cache stable queries. So what is a stable query? It's a query that we see more than once, essentially. So we cache the queries that come in all the time, and so that by caching them, we can avoid doing all that expensive computation of parsing the query, generating the abstract syntax tree, and then validating it against our schema. It's a lot of execution. In fact, these can actually dramatically improve the performance of our application. Now, this result might be a little bit old, but the difference gap is still there. Those numbers have been verified also by others. So there's a lot of benchmarks out there talking about Fastify GQL and the other implementation. So take it, check and verify with your own. But you can have this technique can guarantee you huge savings. But then we didn't stop about this applying this basic caching. We did additional performance analysis using Clinic Flame. And it turns out that there was still a lot of things being executed. Like there was even the execution step. It was hard. It was taking a lot of time. So how could we improve it? Okay, how can we make it faster? Well, we can do all the on-the-fly code generation. How hard it will be. You take the abstract syntax tree and you generate some code. Easy, right? Well, turns out that there was a library ready for that, which is fantastic because GraphQL has an enormous ecosystem. Note that when we started doing this work, this library was not there yet. We did a talk with our own implementation, and it turns out that Zalando has built a better one, and so they open sourced it, and here we go. So I'm pretty pleased. Note that this generates the code on the right side of the screen. You will see that is the generated code from GraphQL JIT for some complicated query. And however, using GraphQL JIT can actually improve your application, the execution of your GraphQL queries, more or less maybe tenfold, which is great, right? So yeah, you should definitely try it out and see how you can use it. Well, you can't use it straight away, so you need to embed it into your own app. So Fastify GQL using our caching technique and GraphQL JIT to deliver amazing performance. Let's look a little bit on why that is fast and why compiling it can give us great result. So when we see an incoming GraphQL query, if the query is called, we have not seen it before, we need to cache it and interpret. But then if the query is hot, if you see more than one time, we can actually compile it to JavaScript, which means walking through the abstract syntax tree and generating the big JavaScript piece that I've shown you in the previous slide. This, in turn, is actually phenomenal because when the query is still hot, the JavaScript function is still hot, is still being executed, V8 can actually improve it even further. Let's talk just a little bit of a digression here. When V8 sees a new function, it compiles it to a slow but generic binary code because you haven't seen the types that are coming in, what type of objects, what type of shapes, and so on and so forth. So not super fast. But if he's calling that function over and over again, it can actually optimize it. And it takes that slow but generic function with some execution metadata about what arguments are called, how many arguments, what type they are, what shape, and so on and so forth, and then it optimizes it in fast but specific binary code, which is great, which is super fast. So we can actually get even faster than before. So when using our GraphQL JIT, when using the JIT implementation, it's actually even better. So this was kind of one of the few reasons that when we started using Fastify GQL, it has evolved, it has grown. In fact, right now, we have recently added, some time ago, actually last year, I've added a new feature to talk about nested queries. Nested queries are actually one of the key problems when implementing GraphQL solutions. Why? Let's see that in a second. So this is the graphical web interface, which is very typical, a typical IDE, web IDE you can just install inside your code, inside your app, and it enables you to diagnose and test your GraphQL queries. Now, see that we are running a dogs query that has name, and we get the name and the owner of we have the name of the dog and the name of the owner. So what you can see in normal GraphQL that what you do is that you are actually you need to fetch all this data. Now, a normal GraphQL usual GraphQL implementation that has not been optimized typically does one query for getting all the dogs, but then n queries to getting all the owner for all the dogs. This is how typically resolvers works, which is not, which is a problem, right? Because you will, if n is too big, it will explode your databases, so it would not work. And so you will going to do 1 plus n queries. It's actually very easy to implement this. Like almost every GraphQL implementation suffers from this problem. It can even get worse if you go with the nest, if you nest one more level, because then you have one query, then n queries, then m queries. So many queries, right, for one single GraphQL. Imagine that in order to build this result, we need to call different microservices and from different parts of the company. It's actually very, very hard. In fact, we can generalize this and say it's 1 plus n times m queries. Wow. Can get worse, because we can even say that it's 1 plus n elevated at the depth minus 1 queries. It's a lot of queries to our database. So, well, maybe we can do something better. Of course, we can do something better. The engineers from Facebook and from the GraphQL team have thought of this pattern called the data loader pattern, which enable us to coalesce every same tick query into a bulk query. What does this mean? Well, this means that when you have the plus n, in fact, in that result, instead of doing plus n queries, you will do only one bulk query to get all your owners or all your cities or your addresses. So it's pretty easy. It's a must-have. You cannot implement a GraphQL solution, a GraphQL endpoint, without thinking about the data loader pattern. Otherwise, you will have significant performance issues in your code. With data loader, you actually go to D query, so depth query. So you do one query for each level of depth in your application, in your query, which is actually pretty great. There are a few other modules and techniques to limit the depth. So in reality, this can be managed, which is fantastic. Loving it. Now, let's go one step forward. We have in Fastify GQL, we also implement this pattern. Same thing, but it's actually way, way easier to use than using data loader. And you can just, instead of just specifying the resolvers, we can also specify a new option called loaders, which will automatically do it for us. We don't have to do anything. Just use this other pattern, you get an array of queries instead. It's pretty great. Last topic before we wrap up, it's talking about the concept of federation. Apollo has defined this new concept of GraphQL Federation, which enables developers to build a microservice system, build a GraphQL endpoint out of little microservices, each one of them serving their own GraphQL endpoint. It's pretty great. We have also implemented this in Fastify GQL, and you can easily use it by instantiating Fastify instance with GQL and specifying a list of services. It also adds a few features that they're not available in the original implementation, which, for example, is subscription support, which is great. And you can also use Fastify GQL to implement services built for a federation system, which is also making them compatible with the Apollo implementation, which is fantastic. And you can very easily do them by adding the federation metadata and a new resolver for getting the reference. Not that I'm using the loaders here, because I can get a bulk query of users to get, so it's pretty great. Because it's actually Fastify GQL is focuses on performance. We have also done some benchmarks and some new results, and you can see that we can get almost in a 3x in throughput and a quarter of the latency, which is phenomenal from the starting point we have worked on. So yeah, this is pretty great. So the summary of this talk is, I want to note that GraphQL can become very competitive versus building your own REST-based system, and as well as Fastify GQL and the Fastify community can help you implement that at a bigger scale than what you normally would. So it's I think it's a pretty good tool to have on our belt, and I think that's it. Oh, one more thing. It's check out Fastify is the framework that I have been demoing, which is really nice. We've been working on it for a while. We are at major version 3, and we are part of the OpenJS Foundation. And I would just thank you for your time. As I said, Nearform is a professional services company. We are based in Ireland, but we work throughout the globe. We are on 20-something countries right now. So, hey, and working remotely. So if you need any help with JavaScript, or if you would like to work for a remote-first company in whichever country you are, normally in the European-US time zone. So I'm sorry for the others that are not in those time zones. But we can probably need some help. We will be recruiting pretty soon. If not, feel free to, if you really want to work with us, please feel free to reach out directly to me or to apply with a general application on our website. Yeah. Thank you all for watching, and see you next time. Bye.
So to everyone watching along, can you start popping your questions into the Q&A panel? And we'd love to pop them to Matteo. But I believe we do have some to start us off.
Yep. Okay, so that's
I'm
where
ready.
I come in. Hey, Matteo.
Hey.
So let's start with a big one. With GraphQL has been proven great for APIs by some companies. If you want to put some sort of quotas or throttling on your API, how would you approach that? Because for people who are not aware, it is theoretically possible to get most of your database with a single query out of a GraphQL API. So how would you put throttling on that?
Three sides of this. So there are three sides of these problems, okay? There is a quota on the number of requests that you are issuing to your server, which is in common with REST APIs. So you should have a plugin or a system to deal with that same way in which you deal with for your REST APIs, which goes by into the realm of rate limiting. So this is the first one. And we have a nice plugin for that in the Fastify world. So we call Fastify rate limit, which is pretty great. It also enables, I'm passing it in the chat. So and it's this is a plugin for general rate limiting on incoming requests with based on the incoming IP. This is the first one. The second one that you need to do, and Fastify GQL has this, is the query depth limit. So it's a scan that in the incoming query, it limits the maximum depth of a query to a certain amount. We have seen that the number of database queries that a request can do can be limited to D queries, so the depth of the query. So because of that, limiting the depth actually limits the amount of queries that you are going to issue to the database, the data loader pattern. And third, you must, and this is up to you, developer, implement pagination of your results, because if you returns all the records without paginations and limits on your using an endpoint, then it's up to you. It's your fault.
Yeah, definitely. Now a tiny twist to this question. So if this is a commercial API and my customers would be paying for that, I don't want to limit them. I want to charge them proportionally to the resources they're using up. How would you approach that kind
This is very hard. This is a
situation?
very hard problem. So it really depends on how much so you can, depends on what your paying model is. You can pay per number of GraphQL requests. You can, which is, you can get the word out of it. So big question. You can pay for the processing time or something like that of the query, but that's very hard to measure because there's a lot of other things that can be involved. So another way, it's what I would do is essentially let people pay by nesting. So again, even the best you can implement your query is the depth of the query itself. So maybe have them pay by depth, essentially. So, which means like nested resolvers to some extent in other things. So, which is way simpler to count to some extent. So, or by other entity.
Yeah. I'd say just take the money off them in any way you can.
Well, yeah.
Per field returned.
Yeah, but it needs to be simple for people to understand what they're paying for. So, it's and all the systems that I'm seeing that are making them pay for GraphQL endpoint, they're for each GraphQL queries and so on, they're really pricey, like really pricey right now, from what I've seen online or something. So I've seen a few CMS online that let you pay for GraphQL queries, and that's it. That's those numbers that they put there that are free tier or the lower amount, they're actually very low. So, the moment you start pushing some traffic through them, you would be in huge trouble.
What's the reason for the high cost? Do we have a suspicion?
Oh yeah, totally. Like again, running GraphQL, like from my understanding, running server is very, very expensive overall.
Okay.
It's just a lot of resources to parse those queries, validate those. I spoke about this in the talk, but there's a lot of things that happens on GraphQL to make things happen. And essentially that cost come down at the origin. It's more or less number of GraphQL queries per server that I can handle at any point in time. And if I'm losing, the more I'm losing on, the more it costs me, the more servers I need, the more I need to be paid for. The more cost I have, the more I need to be paid for it. So this is one of the reasons. And the other reason is probably that those servers are niche to some extent. So, and they solve actually a real problem. So if you compare the cost of those services and the time that those services save in development time, the development time that they save, and like people cost way more than servers anyway. So to be honest, it might even be fair to pay them to pay their price. So it really depends on your use case, essentially. If you're making if the service that you're building is going to have some traffic or not, and it might be worth the investment of developing something custom or not.
There's a nice question on the top of the Q&A. What is the most common GraphQL mistake you have seen in your experience? You mentioned one in the talk, maybe something.
Okay,
that
so I probably the biggest one is the 1+n problem. And I've seen this happening. I've seen this in all sort of fashion. Note that the most popular documentations that you can find out there for GraphQL don't mention this problem. I've seen entire talks about GraphQL don't even mention data loader, essentially, and people just, don't even care. And then they blows up in their code. So this is the first one, to be honest, is the 90% of the time versus the rest. Okay. On the rest, there is over specifying the number of resolvers. So essentially, in maybe even using resolvers for non-asynchronous work, essentially, that is probably another kind of a problem that I've seen that can slow people down. Every time you use a resolver, you allocate a bunch of promises. It's a lot of work. It's a lot of computational work. So the more you can avoid them, the better to some extent. Then the last one is, and this is so funny that I'm going to mention because I find it very funny. It's using GraphQL when GraphQL is not needed. So truly, this is probably one of the most common mistakes. The best moment where GraphQL is used is when you have different teams and you need a shared language between the two teams so that they can fetch the data the way they want and you can produce the data the way you need to, and other people can fetch the data the way they want. So, and that can be different, okay? And this is the best use case for GraphQL. If it's me developing some code that I would be using in my front end, why bother? Like old school, if I'm doing a web app, old school REST is probably 10 times simpler to ship and cache and secure and paginate and whatever. So pragmatism, it wins for me over there. So it really depends on.
You just covered another question.
Okay, cool.
Way.
You see,
2 for 1.
Okay, so is there an inflection point? I'm reading another one in terms of scale, the app, where I should just not consider GraphQL at all, where the size of the app will prevent GraphQL patterns from ever being performant.
Sorry, can you repeat the question? I'm lost.
I'm going to simplify. Is there a size of the application? I think by that they meant data and data types, which is too big for GraphQL to ever make it performant.
So from my understanding, there has to be, but I have not seen it yet. So it's probably massive. But on the other side, very important thing, you should be using GraphQL JIT. If you're not using GraphQL JIT, then you're in big trouble. So yes, if you use GraphQL JIT, you're probably the biggest of the way GraphQL JIT works. The biggest the query is, the biggest the improvement you have. So essentially, because it does less work, a lot less work. So if you use GraphQL JIT, yes, it's probably there has to be, but it's probably very, very far away. with the GraphQL, without GraphQL JIT, you are in trouble. You can get in trouble way, way sooner than that. I don't know what to give you a size in inches or whatever, but it's the rest. Like, use GraphQL JIT, and you should not be boring. That's my TLDR of this question.
It's a good TLDR. I've got a little question of my own, and this is purely for my own benefit, nobody else watching along. I've never used GraphQL. Have you got a suggested project type for me to play around with it with? So I'm guessing getting a load of blog posts out of a GraphQL database is probably not a good use of it. But what?
Well, it is. So it is. So it is, and it is not. Okay. So if you need to study it, just study it and play with it the way you want.
Yeah.
To be honest, it's fine. If you need, build a domain, work on a domain that you know, because you need to get used to how you would model that domain. So that is kind of the hard part. So get that hard part done, and then you have a smooth sailing. And that's actually how I would approach it. So start with a project that you know, a domain that you know.
Okay. That's perfect advice. And I think on that bombshell, we're approaching the end of this Q&A session.
Hey!
Unfortunately, but will you be sticking around on the tables for people to come and find you?
Maybe, if I understand how Follow This works. So if you just tell me where I need to click, yes, I have been in huge trouble. I jumped into Luciano Q&A before I made a mess. So I am a little bit at a loss on this platform. So if you tell me where to click, I'm happy to.
Find one of the fairly empty tables and double click on that, and then you'll join it, and then other people can come and find you.
Can you join me? Can you?
Other people will be able to join you. Yeah.
Okay, perfect. Yeah, let's do that. Just send me a link and send me something, instruction, and I will do it.
Awesome.
Yeah. So looking forward to your workshop on Friday.
Is it Friday? Maybe it's the 17th. Yeah. So I don't know if it's Friday. It should be Friday.
Yeah, it's on Friday. Okay.
I'm literally on the lost side of.
I believe there are 6 tickets left for that, if I'm correct.
Oh, really?
So it sounds like something you're interested in going along to. Now's your time to sign up. I think there is a big discount as well.
It's really fun. We are talking about promises, and now they are broken, and the fact that you're using them wrong. So.
Perfect. And with that, I think we're going to have to leave that here because we've got the other talk just about to start. So, Matteo, I'd like to say a huge thank you again for your talk. It was absolutely amazing. It inspired me to dive into GraphQL, and I'm sure it did for other people as well. Have you got any final departing words? Either of you?
Use Fastify.
Use Fastify. Get that plug in there right at the end. Matteo, thank you very much for your time. We really, really appreciate it.
Bye-bye.